Welcome back to Izzo Math. In this video we're talking about the graph of the sine and cosine again, and here I'm going to be using a nice Wolfram Demonstrations project demonstration to see here. If you see here, if we start at 0, as we move around the unit circle, so look, as I'm moving around the unit circle here, the height of the sine of x is what we're actually graphing here. So for example, when we're at pi over 4 radians, somewhere right in there, we measure the height, and that's where we plot our point. When we go to pi over 2, we measure the height here, and so we get a height of 1, so we plot the point there at 1. Okay, on around to 3 pi over 4, we measure the height, and we get the root 2 over 2, and it's about 0.7, so that's where that is. On around to pi, see at pi, the height from the x-axis is 0, so we are at 0 here. And so we go around to 5 pi over 4, we are again at root 2 over 2, but negative root 2 over 2, so that's the about 0.7 there. At 3 pi over 2, we are down here, so we are a height of negative 1. Well, the y-coordinate's negative 1. You can think of it as a distance of 1 in the negative direction. 7 pi over 4. There we go. We're at root 2 over 2 again, so negative root 2 over 2. And so that's going to give me about the 0.7. And then back to 2 pi. And you see that that's going to give me a height of 0. So again, I think this is a really neat demonstration here. That really, I mean, as you go around, you see exactly that the sine measures the height of each point in the positive and negative direction. Okay, so it takes that y-coordinate, and that's where we get that nice curve. And now this curve is just going to repeat itself if we continued on around, or if we continue in the negative direction, it would just repeat itself that way. Okay, so I'll click show value. So at the power 4 is over there. So you see, yeah, we're about at the 0.7s. Anyway, so let's try the same thing with the cosine. If I remember, the cosine spits out the x-coordinate or the horizontal distance from the y-axis. So you see here that the horizontal distance is given by this distance here, which is converted here to that piece. Okay? And so when we're at 0, our horizontal distance is 1, so that's why we're up at 1. And then as we go toward pi over 2, we see the horizontal distance getting smaller and smaller and smaller until it is 0 there at pi over 2. Then as we move toward pi, we see it getting bigger in the negative direction until it maxes out at 1, but in the negative direction, so it's negative 1 there. So at pi. And then you're going to see as we approach 3 pi over 2 that it gets smaller and smaller and smaller until we hit 3 pi over 2 and we get 0. And as we move in this direction and get closer and closer to 2 pi, we see that we are approaching 1 again. Okay? And then it's just going to continually repeat itself as it goes around the circle in that manner in either direction. Okay? I hope this helped you out. I think this is some really neat technology. Again, this is the Wolfram's Demonstration Project. Google it, and these little applications here are free with the Wolfram CDF player. Cool. I will see you in the next video. We will start working on what is going to be next. Ooh, we are going to talk about the tangent in the next video. That is awesome. The tangent is cool. I will see you then.